In the last lesson, we were numerically trying to figure out the optimum volume of a three-dimensional shape. So the shape had to have a surface area of 1,000 meters squared, and we were trying to figure out the best shape and the best dimensions, the best, in this case, radius and height of a cylinder, to get the biggest volume. And we figured out that about a radius of 7 and a height of almost 16 gave us the best volume. So it's a little bit tricky if we wanted to get it to 2 decimal places or 3 decimal places for the radius or height, because we would really have to play with these numbers for quite a long time, get a lot of guess and check. It would take some time. It would help us if we could come up with an equation and do some graphing. So notice that we were picking the radius and then figuring out the height. And every time we did this, we would have 1,000 equals 2 pi r squared plus 2 pi r h. We would know what r was, and we would bring it over to the side with the 1,000 and solve for h. So in general, we are subtracting this term from both sides to move it over. Minus 2 pi r squared equals 2 pi r h. We're trying to get h by itself. The 2 pi r is multiplying the h. To get rid of it, we divide. Okay, let's simplify this a little bit. H is equal to 1,000. If we wanted to, there's a common factor of 2, we could divide things out. That might be a good idea. 2 goes into 1,000 twice, leaving 500. 2 goes into 2. Notice I divide the 2 into every term, so it's dividing everything. 2 goes into 2 evenly, it'll be canceled out. So this gets canceled, and this becomes 500. Pi r squared over pi r. We can't simplify this any further. If you left it as 1,000, if you left it exactly as it is up here, that's fine. This just means a little bit less to type. Okay, so, and then we took our h and we took our r and we figured out the volume. So the volume is equal to pi r squared times h. Now we have a term for h. Once we've picked an r value, we can find the h by doing 500 minus pi r squared all over pi r. So we could actually take this and graph it. You haven't done a lot of graphing like this before. We could just take the points and graph them. But today I'm going to show you how to use GeoGebra, and we're going to graph this. Hopefully it's not so out there. It doesn't that it doesn't work. Hopefully it'll work nicely. So let's give this a try. So it's not going to let me use r. I'm going to have to use x. So I'm going to do pi. I hope it figures out what pi is. I think so. R to the power of 2. There we go. My keyboard was in French. It did not like it. Pi times r squared. Oh wait, I said we're not using r, we're using x. Pi r squared times 500 minus pi times r, we're not using r, we're using x to the power of 2, divided by, now notice if I do the divided by like this, I'm dividing only this last term. I want to divide everything. So by order of operation, I need to put this in brackets. So it'll all be divided by pi x. Now I'm not sure if I did the pi correctly here. And you know what? I see I have a symbol button. I bet it wants me to use this symbol button for pi instead. Let's try that. I'll just try graphing it, see if it lets me. Create a slider for pi. No, I don't want to create a slider for pi. I know what pi is. So we could either put 3.14 here or we could use the symbol. I think I'll do 3.14. All right, let's see if it'll graph it. It graphed it. Excellent. The only problem is we can't see all of it, so we need to adjust the axes here. We're trying to see the shape of this graph. We're trying to figure out what the maximum volume is. And we knew from what we did over here, we know the maximum volume is about 2,400, about 2,400. And I'm at about 1,200, so I have quite a bit more to go. There we go. There it is. There's the maximum value. It's right around here. If I can place a point on it, I could drag this point around till I see the highest number, 24.28. Oh, I want to see a little bit more here. Okay, 28.49. Now it's going down. 28. Okay, I think that's the best I can do. So with a radius of 7.28, our maximum volume would be 2,400. For a cylinder, is the cylinder the best shape? Let's figure out what it would be for a square-based rectangular prism. We are going to try to maximize the 1,000 meters squared of material we have, and we're going to try to do it with a rectangular prism. So the rectangular prism has 6 faces, and all of the faces are rectangles. We know that to maximize the area of a rectangle, we need a square. So let's try to do ours with a square base. So we have a base, the length and the width is b, and a height of h. Okay, so what do we know about this? We know that the surface area is equal to 1,000. So we could use the formula we have here, 2 times width times height plus length times width plus length times height. But in this case we have a lot of repeated values, so let's just make up our own formula. So we have 1,000 equals, okay, so we have the base is this square here, and the bottom is like that, and the top. So we have 2b squared. The area would be b times b. There's 2 of them. 2 times b squared. Just going to erase it from the shape so we can see all the other faces. Now, all the other rectangles are base times height. Every single one. Base times height, base times height, base times height. All four of those are base times height. So we have 4 base times height. Okay, so this is an equation for the surface area. Similar to what we did for the cylinder, we want to be able to pick one of these values and solve for the other one. So we want to maybe pick B and solve for H. So we'll need H by itself. So we're going to use the same steps to isolate H. We're going to have to subtract the 2b squared from both sides. 1000 minus 2b squared. We subtract it from the right-hand side, so it's gone. And we have 4bh. Okay, we want to get h by itself, so we can divide by 4b. 4b. And we'll have 1000 minus 2b squared over 4b is equal to h. Now, technically over here on the left-hand side, we could do a little bit of simplifying. Every term here, every single term are even numbers, so we could divide every single term by 2. Divide the bottom by 2 and be left with 2, and divide the top. When we divide the top, we have to divide both terms. 500. 2 divided by 2 is 1. So we can simplify this a little bit more. H is equal to 500 minus, that's looking very messy and not quite correct. Okay, we had 2 and we divided by 2, we were left with 1, and we still have the b squared. All over 2, all over 2b. Okay, so now we know what h is in terms of b. If we pick b, we can find h. Let's write an equation for the volume. So the volume of a rectangular prism is usually the area of the base times the height. Area of the base is b squared, times the height. We have the height over here, 500 minus b squared, all over 2b. Great. So now we have this equation, and we can use it to graph the relationship between the volume and the choice of variables. So I'm going to make a new graph here. Let me pull this down so you can see all the buttons I'm pressing. So if you want to make it in GeoGebra, you can too. Oops, don't disappear, GeoGebra. Okay. So we want to input this, and remember we have to be careful when we input it. Hopefully we'll do it perfectly the first try. So we have b squared, and remember that GeoGebra doesn't want any random old variable. They actually want us to use x's. So x to the power of 2 times, in the numerator, 500 minus b squared. Uh-oh, it didn't like that b. I better go back. It's expecting x divided by all of this. We'd want to put brackets around the denominator so it knows it's all in the denominator, divided by 2x. I opened 2 brackets, 3 brackets. Have I closed all my brackets? I think so. If this graphs, it should be correct. Okay, we can see it starting here, so let's adjust the scale so we can see what's happening. We don't really see much of the behavior. All we see is a big, huge vertical something. We don't even know if it's a line or a different shape until we zoom in more. Okay, let's try to find the maximum value. And oops. I like to be able to see over here. We can see this point. Okay, what's the maximum? Just play with this point a little bit until we get a maximum. It looks like it's 21, 51.66. I think so. I can use the arrow keys to move around, but they do jump quite a bit more than I want them to. When I was dragging it, I was getting more precise. So okay, I think that's the best we can do. So let's write down this point. Looks like it's the maximum. 12.92, comma, 2151.66. Is that right? 2151.66. Okay. So this means the variable we had was the base. For a base of 12.92, we have a maximum volume. This was our maximum volume. So what this shape means, you'll study it more in grade 10. This shape's called a parabola. It's like an upside down U shape. And wherever this parabola has the top of the hill, it's a maximum value. So since the y values here represented the volume, it's the maximum volume. And if we had a different shape, and if it was a U that went in the other direction, like say, let's see if I can get this shape to change. So it's not quite a parabola, it has some other dips to it, but it's a curve. We can say it's a curve. So with this curve, it has a minimum value right here. It dips down, hits a minimum, goes back up again. So it's often very helpful when you're doing an optimization problem to be able to find the highest or the lowest, because it might represent the best of something.